Hello guys, welcome back to class. In this session, we'll continue the list, exploring list. So about the list, what we have seen in the previous session, we have seen how to create a list object. Using the list object, three options we have seen. One is creating a list using square bracket. Next, creating a list using constructor. Creating a list using list comprehension. Three techniques we have discussed, right? Three techniques we have seen for creating list. So after finishing list creation using three approaches, we have seen list operations. So we have indexing, slicing, list concatenation, list repetition, list membership with in operator, not in, and using the for loop for iterating the list elements, right? We can also use list comparison operators. I think we have discussed up to for, am I right? Up to for completed. List comparison is not discussed. Am I right, guys? Right? Okay, let's start with the list comparison. That is the early question, Premchand. We will discuss about that. Still, that is not yet covered, Premchand. Enumerate method is not yet covered. We'll discuss that. That is a most important method. We'll discuss about that. Fine. So let's start with the seventh operation, which we can do on the list, called list comparison. Our regular comparison operators like equals, double equals, not equals, less than or equal, greater than or equal. These operators also can be used on the list. These operators also can be used on list. So here we have a two, equal, equality and inequality are not equal. And also this less than, greater than, we can use for a lexicographical comparison. I hope you know what is lexicographical, right? So let's start. So how it works? How it works? The rule is, for example, you take the first one, lab 18. Lab 17 we discussed previously, right? Lab 17 we discussed 18. Equality and inequality. So I have a list 1 which has three elements, 10, 20, 30. List 2 having three elements, 10, 20, 30. List 3 having three elements, 10, 20, and 40. Okay. So when I say L1 equals to L2, we are comparing the list. Here, it won't compare the addresses. Generally, what is there in L1? When you create L1, what is there in L1, guys? L1 contains the address of the list. Am I right? L2 contains the address of the another list object. But it will not compare the addresses. That is the implementation done here. So equals not only for numbers, it is also for reference variables, especially for the list like this. So, okay, so it's not comparing addresses. How it compares? See the rule here. I written an important point to remember. What is the rule to compare? Comparison happens element by element. Comparison happens element by element from left side to right side and stops as soon as difference is found or a mismatch is found. Stops immediately whenever a mismatch is found. If mismatch is found, then it will stop and returns the false value. Suppose you take the case of L1 equals to L2. So in this case, it compares the elements one by one. So it will compare first element, same only. Okay, move on to second, same only. Move on to third, same only. all are same. So in that case, it returns the true value. So first is returning the true value. And second, suppose if I say like this, I'll add one more statement here. L1 equals to L3. What is the result of this? L1 equals to L3. It should be false. It should be false. So why it is? It's comparing L1 elements. L1 contains start for the first 10 and 10, 10 and 10 matching, then move on to second 20 20 matching, move on to third 30 40. So this gives 30 not equals to 40. So whenever a mismatch found, it stops and returns the false value. And L1 not equals to L3, or I will say L1 not equals to L3. True only. L1 and L2 are not equal because there is a mismatch. So it is connecting for CPU. You are done. See, we have first one true, second one false, third one true. Is this clear? Alok, the logic is very simple. It will compare, that's what I have written for you, a sentence. Comparison happens element by element from left side to right side. So as per the example taken by Alok, your L1 is 10, 20, 30. Your L2 is 10, 30, 20. So how it compares? First it compares the first element 10 and 10. Okay. Then second element 20, 30, not okay. Then it stops and returns the false value. Clear? Right? What is the Shishakar? In the case of equal internally, will it create two separate lists? Okay. Now your doubt is here, any pooling technique is there for the list or not? We have discussed a pooling technique previously, right? So what are the cases? What are the cases where pooling is used in Python? Tell me that. What are the cases where pooling is used in Python? Strings is the one. Okay, strings are immutable. Strings are immutable. So it will use the pool, reuse it. And what else? Sanjit, tuples also, but tuples we don't know as of now, leave it. You tell me whatever we completed. Very good, Satish. Small numbers, right? Numbers up to some range. Small numbers will be reused. Now, lists are mutable. Mutable means we can modify those. Now, pooling is used or not. How to check that? How to check that? Try to print the address. Address of L1, address of L2, guys. So, print address of L1, L2. How to print address of L1? Tell me that. How to print address of L1? ID, Sanjit, very good. Address of L1 I am printing. L1, L2 pointing to the same list only. It means the content is same. Whether it is going to create a new list or not. That's what we are cross-checking here. See the addresses? Addresses are different. It means, Shivsagar, there is no reusability in the case of lists. There's no reusable in the case of lists. Okay. Always list will be created freshly. Okay. You add the comment here. No pooling for the lists. No pooling for the list. So we are printing addresses. So from that we are comparing the point. Okay. So equality we are done. Let's move to the next lab number 19. We are trying to use less than greater than here. So I'm taking my list as L1 is 10, 20, 30. L2 is 10, 20, 40. L3 is 500 and 200. Right? So L1 less than L2. L1 less than L2. So when you do this, how it compares, guys? One by one, but one by one positionally, yes, but first element same only. When a first element is same, it is going for second. Second is also same, then it is going for third. Now, third if same is different. But here, third case, wherever a mismatch found, the mismatch, what do we want to check? Less than we want to check. So it is checking 30 less than 40. The last mismatch is 30. So it is checking 30 less than 40. 30 less than 40 is true. So it has to return the true value. Next, L1, L3. I am writing L1 greater than L2. So it is checking first only mismatch. So first only mismatch means it is checking 10 greater, first L1, L3. 10 greater than 5 is true. L2 greater than or equals to L1. So greater than or equals to L1. So 40, 10, 10. L2, 10, L1, 10. Same. L2, 20, L1, 20. Same. Then 40 greater than 30. True only. A greater than or equals operator used. It is going to create all. I'll just add some more expressions for checking. Now, if I say L1 greater than L2, what happens, guys? What is the last check it is doing? First 10, 10 same, 20, 20 same. Then it's going to take 30 greater than 40. 30 greater than 40 is the false only. So it will return the false. Next, this also I'll make L1 less than L3. So L1, L3. L1 is the 10, 10 less than 5. 10 less than 5 is okay, right? 10 less than 5. 10 less than 5 is the false. So it will stop. Let's rerun this. See, true, false, true, false, true. Is this clear, guys? Okay. Okay, Purushottam, question is, what if it has a different elements? Okay, I'll explore that. And what else? Prahalad, 5, 30, 40 and 2, 200. Okay, what is the question on this, Prahalad? Currently, don't see where we will use this. So we have lots of scenarios. Currently, you learn the syntaxes, how to use examples. We have so many use cases where we will use this. Okay. So many use cases in future when you're learning pandas, numpy, and when you write machine learning algorithms. We have machine learning algorithms are for a large amount of data to process. You may have a list with the 10,000 elements. You may have another list with 10,000 elements. 10,000 elements, 10,000 element size, two lists are there. You want to compare that. Instead of you writing a loop, they given a simple operator, right? Fine. So, okay, we're done equality less than greater than all this. Fine. Abhishek, your question only coming up. See, you may have a strings also. Strings also you can compare. You can write a simple program with string comparison. It works. Abhishek, it works. You can try that, or if required, I'll write it. But see, I'm taking a mixed types. Okay. If you want, you can write a simple program, guys. Because if I write a program, my lab numbers will change. So fine. I am taking a list one as a 10, apple, and 30. So can I have different types of elements in my list? Yes, list is heterogeneous. I can have different types of elements in this. So I have a 10 apple, 30, and 10 banana, 30. So two lists are there. So when I say L1 less than L2, what happens? L1 less than L2, what happens, guys? You are seeing output to true, so you are telling maybe fine. But how it works is, how it works? 10, 10, same. Very good, Alok, you're right. ASCII, S. Lakshminath, you're right. Apple less than banana, correct. First element, 10, 10, same. Okay, leave this. Come to second element. This is not same, mismatch. When I mismatch, it compares the apple less than banana. So in this now it compares again the character by character. First character A less than B. Small a less than small b. Small a 97, small b 98, ASCII values. So 97 less than 98, so true. It returns the same thing. If I say L1 greater than L2, it will check. You are asked, means directly you are saying apple is greater than banana. It has to give a false value. It has to give a false value. This is true and this is false. And here I written one condition for you. See this. When you go for comparison, careful with the comparison. Why I have to be careful? Where I have to be careful? Only similar types will be compared. 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 So here in the above examples, you see number only, right? Number comparison, okay. In this lab 20, I am taking string and string comparison, okay. But if I take example like this, my L3 is 10 comma apple, L4 is 10 comma 20. When I apply this, you will see the, when you compare L3 less than L4, so it will start comparing first element 10 and 10. Okay, 10 and 10 same. Then move on to second, string and int. You cannot compare string and int. It gives the type error in Python 3. String versus int comparison is not allowed. Let's see the error also. See, I just copied the same error for you. This error message. Type error in Python 3. String int comparison is not allowed. Only similar types will be compared. So why I told you should be careful in the comparison, guys. Careful with comparison. Only similar elements will be compared. Fine. Okay. Question from Sanjit is, in Python, we don't have a char data type. Yes, you don't have a char data type. It means you cannot declare a variable to store a single character. It doesn't mean character support is not there. Any programming language must support a character set. Every character you write will have an ASCII equivalent internally. That is common for all the programming languages. Any language, any programming language you consider, you have some character base ASCII only. Base ASCII only. Clear, Sanjit? You cannot represent single character in a variable, but the character comparison, yes. And we have two methods also we discussed. We discussed two methods also. If you have a character, single character, you can get ASCII value. If you have an ASCII value, you can get its character. Have you remembered two methods we discussed, two global functions we discussed? If you know character, you can get ASCII value. If you know ASCII value, you can get a character. What are the two methods we discussed, guys? If you remember, type there. Very good. Odd, CHR, Nitesh. CHR, yes, you are right. Odd and char, two methods. So that is clear. Next, I think this is the question asked to Purushottam. You have already, for your question, you have the answer here. So what if I have lists with different sizes? List with different sizes. Whenever a size different, read this point, guys. It is true. Why it is true? Shorter list is smaller if all elements are equal. It means first element 10, 10, same. Second element 20, 20, same. Now, third element I don't have in the list one, but I have in this. So I can't do comparison. At this case, what it will do is, it will see that first list is a smaller size, then is the length 2 less than length 3. Then the less than is okay. Suppose if I do this, tell me what happens. L1 greater than L2, it gives a false. I'll take one more example on this. Let's do like this. L3, L4, this is 10 and 2, something like this. Ten and 25 I'm taking as. L3 less than L4. Tell me this. L3 less than L4, guys. All falses, Vivek only true. Explain, Vivek, why true? Abhishek also came and joined with Vivek. False, guys. False. Most of you guessed as a false. Very good. See how it works. L3, L4. First is the 10, 10 same. Okay, leave it. Move on to second. Second is a mismatch. When I mismatch, it applies 25 less than 20. This is the false. Understand? This first one you see. First one you see how it works, I am telling. In this case, L1 less than L2. First it is telling 10, 10, same. Okay, leave it. Then 20, 20, same, leave it. Next, we don't have a comparison, right? Here, no element. Now it checks length of L1 less than length of L2. This is true. The sure final result is true. And in this case, finally checking 10, 10 same, okay, go to the second element, 20, 20 same, next go to next comparison, I don't have anything. Then it checks length of L1 greater than length of L2. Then comes 2 greater than 3, which is the false. That's what this is giving as false. This L3, L4, 10, 10 same, move to next 25, mismatch. Mismatch means then 25 greater than 25 less than 20. So false, giving as false. So I think you got clarity on all comparisons, guys. Mahesh, yes, Mahesh, mixed, I used a mixed means it can have a different types of elements. One integer, one string. Or if you have one integer, one floating, also a mixed list, right? Heterogeneous types. I think Mahesh, you missed my point, Mahesh. You see this point, Mahesh? Read this. Mahesh, did you get your answer? First is int string, second is int int. In that case, can I do comparison? Why it should stop in the first element, Mahesh? It should not stop in the first element. Because first element is, that's what I told the rule number, you read, guys. Comparison happens element by element from left to right. It has to start from first element. See that point again, you please read, guys, everybody. And stops as soon as the difference found. Only it stops when a difference found. So every case, it has to compare the first. So first comparing 10, 10. This case I am telling Mahesh again. 10, 10 same. If same, why it has to stop? If same, it has to move to next element. Then it is comparing string and int, which is not allowed. String equals to string less than integer comparison is not allowed. That's what we'll get error, and that's what this line is commented. Clear, Mahesh? Then Umesh, yes, any primitives you can compare. What are the not primitives, simple types? What are the simple types you have in Python? Simple types, or any type can be compared. Any types can be compared. Integers, floating points, strings, booleans. Any types can be compared. No problem. No, I think you didn't understand, Mahesh. Comparison is not possible. It is giving error. Then why you are thinking about a false? False or a true is a result. False or a true is a result. False or a true is a result. When expression is evaluated successfully, you will get a result. True or false? But error is coming here. Cannot be compared. Follow carefully. See, I written wherever you have to understand important. Careful with the comparison. When you should be careful. When you are comparing same types, no problem. You should not compare different types. Different types case, again, you should not all different types. String int cannot be compared. String float cannot be compared. And can I compare? Yes, Abhishek, it has to give an error. I'll test your knowledge, guys. L5 equals to See, you are not understanding, I think. You apply a basic rule, guys. Whenever two lists are there, first take the first element. Same, whether it's comparable or not. If comparable, it will compare. If not comparable, in the case of 10 and string, integer and integer, okay, you are written as a string and string comparable. String and string comparable means it will compare same or not, equal or not, less than or not. It will decide based on that. First, comparable or not comparable. I think some questions you are going as a more and simple, guys. I think those you can guess it or you can do experiment. Like this means our course will take 2 years. You answer this. Some basics you can do experiments actually. Fine. So answer this. Print L5 equals to L6. L5 equals to L6. Is that true? Integer, floating point are numbers, right? Numbers are compatible and comparable. Numbers are compatible and comparable. Numbers are compatible and comparable. Only string int has a problem. String object is different, int object is different. String int cannot be compared. String float cannot be compared. Int float, yes. Value also same only. 30, 30.0, both are same actually. This gives the regular, if we compare also same. Okay. One more point to explore on this. L7, L8. This is 0. This is keep 30 only. And this is true. Think carefully, your all old knowledge, apply everything you studied and answer this last. L7 equals to L8. So two groups are there. Whoever telling false, can you explain how you concluded as a false? In Python, what is a true? 0 is a false, right? And how true? 0 will be considered as a false. True means non-zero. Yeah, some of you assumed as a 1 is a true, not 1 is a true, guys. Not 1 is a true. Any number, right? Non-zero is a true. Non-zero is a true. Non-zero is a true. Okay, that point is clear. But now int and boolean are compatible or not? Int and boolean are compatible or not? First, if compatible, then 30 is the non-zero, which is true. Then a true equals to true is allowed. Then it will give whole value as a true. If int and boolean are not comparable, it gives a type error. Let's check. It's giving as a false. Giving as a false. Why false? The last result as false. So we assumed as either type error if comparison is not possible. But we got the result. It means We got the result, means comparison is happening. Comparison is happening. But we got a false. In this context, in the list comparison context, it is not considering your number as truth. Your number as true. Right? So, number comparing, any number comparing with the Boolean, this list comparison operator considering as a false. Mismatch, it is considering as a mismatch. So, when mismatch means it stops and gives the result as false. So, I think all the combinations we discussed for the comparison, guys. So, when we will get error? We'll get error only in one case, that is the string int comparison, string float comparison. And other combinations, we understand this. Okay? With this, all the operations complete, list comparison completed. Next, global functions. Some of the global functions we already discussed, and those we can use for a list, and some more global functions I'll be introducing here. So let's start with global functions. So we have the global functions to discuss here with the list. Importantly, length, max, min, sum, these are very easy to understand. I think no explanation required. Sorted, reversed, we need to discuss. Then any, all, enumerate, zip. These are the 6 important global functions. Why I am calling as a global functions? Because these can be used with list, can be used with the tuple, can be used with the set, can be used with the dictionary, like multiple ways we can use. Use with any types. That's what. So first 4 is simple. Length. Length returns the number of elements. I have a list with the 5 elements. When I run this, it gives a list of 5. Next, max gives the largest element. Largest element for comparable types only, guys. Comparable types. Why I am writing specially comparable types? Tell me what is the key point in this? What is the key point in this? Why I written a special note for you for comparable types? Max for comparable types. For a min for comparable types. What is the key point you have to take from this heading? Because all must be comparable. I have numbers, so numbers can be compared. When I'll get a problem, suppose if I take this as 30, I'm taking in a string. Inside the string, whatever it is immutable for me, but the something which is enclosed in a double quotation marks is a string. Now tell me, this comparison is possible? Max, as expected. See, you cannot do comparison. This is not supported between string and int, right? So comparable types. Fine. Same points, Anek, same points here. When you apply max, internally it has to apply greater than symbol, right? How you check a max? First you will compare 10 greater than 20, right? Max means first you will see 10 greater than 20. Next, whatever result coming, the result greater than 30, whatever result coming, result greater than 40, something like this. So the two values you are comparing, greater than, less than, whatever points we discussed above, Boolean comparison, string comparison, and number comparison or integer or float, whatever the rules we discussed, same rules here also. You have to take down these points, guys. You do these experiments as an assignment, you will get more clarity. Okay. Say I have int greater than int. Is this possible or not? You check. Right. Next. Int greater than float. Can I do this? It may be greater than or less than, whatever. Next. Int greater than any bool type. this you do it. Int greater than string. Next. Float greater than bool. Float greater than string. Next. Bool greater than string. Any combinations are there still? I think I have written all combinations, guys. See, all combinations done. Any combinations missing? I think I've done all combinations. So by this time, as per my previous explanation of the comparison operators, I hope you got the answers for this. I explained all this in my flow. So if you didn't get a clarity, you missed the points when I'm explaining. After the session, go home. You write a simple program. You take int and int comparison, happening or not, int float happening or not, int bool happening or not, how it is working, int string happening or not, if not happening, what is error? So which case is giving error, which is allowed, please do the homework. Okay, you write down this. Okay, come back. Next, min also simply finds the min value, and same again, it has to compare internally, right? To compare, they must be compatible. For which are compatible, which are not compatible, we have here. And also you try this, guys. Another string greater than string. Can I do this? This you answer it. I told it. This also I told. At least answer this. String greater than string. Yes, right? Because I told you apple greater than banana, right? Yes. You also try this assignment. 9. List greater than. Can I apply the greater than for list also? Yes. Can I apply for tuple also? Yes. We will talk anyway tuple later. But the 10 points are given. This 10, you understand it. Okay? You do that so that it will rest in your mind. Min, done. If you know that which is allowed, which is not allowed. Yeah. Next to sum. Sum also. Sum is only for numeric elements, guys. Remember it. Sum is only for numeric elements. If you apply string and string, can I do the sum of a string and string, guys? Sum for a string generally no, right? Sum is only for, so it does not support int plus a string is not allowed. Int plus a string is not allowed. This we discussed already, right? So it is only for numeric. Okay, the basic things done. Okay, let's start with important. Now the sorted. Sorted is a global function we can use to sort any kind of data structure, either to sort list, a tuple, set, whatever you want. Any iterable you can use. So using the sorted, I have a list 20, 30, 20, 50, something like this. You just pass the my list as a parameter for the sorted. See, sorted is not a method of list class. Sorted is not a method of a list class. Remember it. It is not a method of list class. It's not a method of list class. It is a global function. For this, you pass anything. Okay, guys. Now, if it is a method of, for example, if it is a method of a list class, how you call that? Tell me. If it is a method of a list class, how you call that? If a method of a list class, how you call that? My list dot sort, something like this, right? Very good. You make a difference. Okay, number one is a global function. Our heading is a global function. So we're talking about a global functions here, which can be used on any other iterable objects. Okay. Now my question to you guys, whether it is sorting a list, whether sorting is happening in place or it is creating a new list with the sorted elements. Question is whether sorting is happening in place or creating a new list. By seeing the code, you can guess it. Very good. It is going to create a new list always. It is going to create a new list always. The new list I am storing in a separate variable called s list. And if you try to print your original list, my list I am printing, my list is not changed. My original list is not disturbed. Am I right? See, your original list remains the same. So sorted will not do the in place sorting. It will do always a sorting in a separate list. Fine. Sorting is done. Next. Reversed. Reversed. Same. It returns the iterator of a list. Actually, this is iterator of the list. So I have my list 10, 20, 30, 40, 50. Then this also same guys. It won't do in place reversing. It will create a new list. It is going to return you iterator object. That's what the reversed method, a reversed function, a reversed method returning iterator. That iterator I am passing as a parameter to list class constructor. So I am getting a R list, reverse list, and printing the reverse list as 50, 30, 40. This is also not in place. So it's creating a new iterator object. My original list is not updated. Clear? Fine. Now, seventh, any returns true if any element is truthy. This is the point you have to understand more clearly. What is if any element is truthy? What is the meaning of truthy? Truthy, falsy. Two important terms we have to understand. This already we discussed, truthy, truthy, which is called as truthy, falsy. Truthy, falsy. What are this? Tell me. What is the meaning of element is truthy? Truthy means true is a truthy, right? True is a truthy. Non-zero is a truthy. True is a truthy. False is a false. Non-zero is truthy. Zero is a false. 0.0 also a false. 0.0 also a false. So again non-zeros. Non-zero, it can be a positive or negative truthy only. Am I right? What about empty string? Empty string is falsy. Empty string is falsy or not? Yes. So non-empty strings. Non-empty strings. Okay, these are the truthy and falsy. So you understand what is truthy, what is falsy. Okay. Now, what is the function any? Any function checks if any element is truthy, it returns true. Check first one. My list has 0, falsy. Okay, leave it. Come to next element. False means falsy only. Next. Suppose next also I am taking as 0.0 guys. Comma. I am taking next as empty string. Just keep it, I'll use it later. You tell me now. I changed the code. This you tell me what happens. It has to give false, right? No truthy. Falsy, 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 falsy. All are falsy. All are falsy means because of any element is truthy, then only it returns true. Otherwise, okay? So it gives the false. Done. I will check one more like the previous only. This is the file. One truthy is there. So this gives the first is the false, Second is true. Is this clear? Clear, guys? Any function? Means we are checking that, know how already we discussed this, Anik, we discussed already this truthy falsy concept already we discussed at some point, beginning only we discussed it. No value, right? No value is considered as a false. There's no, we can't say why it is, how it is. For example, if you take languages like Java, your Java case, Boolean is different and int is different. There's no compatibility assumptions there. But in Python, it is assumed as 0, a false value, 0.0, a false. Empty string means no value, right? No value, false. Boolean value, false, false. These are four falsy cases. Truthy cases, any string with characters, any number of characters, any string you have which is a truthy, equivalent to true indirectly, right? Then any floating point number, positive or negative, any integer number, positive or negative, also will be considered as, okay? That is, these are assumptions for truthy and false. Important, guys. These truthy and false assumptions are very, very important. These are all, I am covering most important points and more in depth. So these all I am spending a lot of time. It means in future context, we need this, understand clearly. And okay, let's come back. What about none? Tell me, what about none? What about none, guys? None also we discussed, I think, as I remembered, I discussed this. So I've taken a 0, false, none. 0, false, none also here. Giving as false. None also, nothing is there, right? What is the none representation in Python? None means nothing, right? Yes, you keep this also here. I hope you are maintaining any running notes. Now, when you are listening the class, if you are maintaining any running notes, it will be good. Otherwise, no problem. Now listen carefully. Later make yourself time and you neatly revise, play the video and write down all the points, all the important points. Okay, guys, done. About any function is clear. Next, come to the all function. Returns true if all elements are truthy. Returns true if all elements are truthy. All elements are truthy. Any means any one is truth, it will give truth. Suppose I have a 10, which is a true, and 5, and none. Okay, let's start with the first one. Tell me the first one. Whether all are truthy? No, false. First only 0, false. First only false. Stop it. Return the false. Okay. Next. Second one. Second one. Second one, guys. Second one. Second one. All are telling true. Second one. Is it true or false? Second one, most of you told false. Very good. Third one, very good. Last is a all truth, right? 10, 10, non-zero, truthy, true, truthy, 5.0, truthy. This is a string. Inside a string, what is there? It is immaterial to me. String, double quotation found, string only. Some characters found, yes, truthy, all truthy, right? All truthy. All truthy means returns the true value. And second case, first 10, truthy, true, truthy, 5 or 5 or 5.0, whatever, even negative number you take, no problem. Last is the falsy, one falsy. All, in this case, if all truthy, then only return true. One false, one falsy, so returns the false. So here none is a falsy. None is falsy. First case, two falsy found, it stops that. So clear, any function, all function dealing with truthy and falsy. Okay. Next, enumerate. Useful sometimes. Useful sometimes. Enumerate returns an iterator. Returns an iterator with index and value as a pair. Index and value as a pair. So sometimes you want indexing. For example, I want only values, guys. I just want to print the values of a list. How to print the values of a list? I can use my for loop for suppose x in or value x for value in my list, value in my list, value in my list colon, then you say print my value. So each value you are taking and printing it. Each value taking and printing it. Okay, I'm printing all values. Fine. This is a common, we have seen already. But sometimes I want indexing. I want element and its index also I want. So you can prefer to use enumerate. Enumerate gives you pair for every element. Its index plus value. So enumerate of my list. What it returns? Two things, index and value. So I am storing those in a two variables. Easy way, right? So easily unpacking the pair and giving it as one into my index, one into my value. Just two variables I have taken as my index and my value. And I'm printing it. So index is this. I'm using F string format. This is just to make a format. If you want other simple style, yes, you can use it. Index 0, value 10 is there. Index 1, value 20 is there. Okay. So enumerate is clear, guys. Yes, says she. First is the index, second is the value. See that it is a pair of index comma value. It's a pair of index comma value. Pair of okay. I'll introduce about Anik. I'll introduce about each one. Don't worry. At the appropriate time, I'll introduce each one. Okay. I didn't. Okay, we'll see that. Don't worry. Next. So enumerate is clear. Moving next. Zip. Combine multiple iterables element wise. Multiple iterables element wise. Iterables element wise means iterables are what? Iterables are what are iterables? List, set, tuple, even string, all are iterables, right? Yes. Any iterable, because we are talking about global functions. These all functions Again, I given examples with the tuple also, with the set also. There I won't explain, but I just given the same examples with the tuple syntax, set syntax like that, but concept same, anything. So element wise zipping, pairing will happen. Kind of pairing will happen element wise. So let's start how it works. First one, I have a my list 1, my list 2. My list 1 has a 5 elements. My list 2 having 5 elements. It can be anything, guys. Your elements in the first list can be any type. Your elements in the second list can be any type, no problem. When you do zip, so zip of my list 1 comma my list, what it is returning? It is returning iterable. It is returning iterable object. So iterable directly we can't access. So I'm converting the iterable to a list passing the constructor. I have a zipped list here. I have one zipped list. Okay. I'll just use simply z list, zipped list. How it is zipping? See, first element of first list, first element of second list. See, as a tuple, right? 10 comma A, second and second, 20 comma B, third and third, 30 comma C, fourth and fourth, right? Fifth and fifth, sixth, each one. Simple. Next. So I have again, definitely your next question, I know, that's what I read on the next also. Your next question is, what are the different sizes? Like my list has 10, 20, 35, 5 elements. Second list having only 3 elements. So then when I do this, 10A, okay, 20B, okay, 30C, okay. We have still 2 more elements. We have still 2 more elements in the list 1, but we don't have elements to pair in the second list. So it stops. Only matching size it will pick, ignores the remaining in any side. Ignores the remaining in any side. It is not a dictionary. It is not a dictionary. It is. Can you tell what it is? Is it a dictionary? See the output, guys, first. See the output. What is the result? What is the result you got? List only. List of what? List of what? List of tuples. Very good. List of tuples. Very good. Clear? Zip is clear. Any doubts on zip? Zip is clear. Any doubts on zip? Can I move forward? Okay, done. So the 10 important global functions we discussed, guys. These all we will use for, we'll use it for all types of iterables. Return type of, what is the return type of zip? You can guess it. I told already in my explanation also, but by seeing the syntax, you can see this. What is the return type of zip function? Return type of zip, guys. Very good. Some of you answered it correctly, guys. Iterable, not the list. Deepak, Umesh, not the list. Iterable. If it is a list, why I'll create again a constructor? Why I'll create a constructor? Let's do it. Print of. Iterable is coming directly. We can't go for print of type of zip of this. It gives an iterable object, guys. Just print this. Zip. Zip is again iterable. Directly zip class object. So we can't directly use that. That's what I'm converting into my own style called list. And internally it contains tuples. each pair as a tuple. Each pair as a tuple. Okay. That's about these global functions. There are many uses, Santosh. We will see those real-time use cases once we start our data science libraries, machine learning libraries. We will use those many places. We will create data frames. Maybe if you know already, fine. Otherwise, it is going to create unnecessary context. Anyway, we'll use that. Now, you learn the raw things, raw material required, all points, you learn. Then we will use all this in many real-time use cases further when you start our data science libraries and machine learning libraries. Okay. Now, so we're done a global functions 10 important. Then methods of a list class. List itself a class defined which has lots of methods inside that. So we have a methods in the list. So first method is the append. Append adds the single element to end of the list. Adds the single element to end of the list. So simply adding, but using a method at the end of the list it is going to add. So I have a list called 10, 20, 30, 40, 50. When I print it, it will print that same. When I say append of 99, so what it does? Ten, 20, 30, 40, 50. It adds a single element only at the end of the list. At the end of the list means 99 will come after this. Okay, append 1, 2, 3. Next to that 1, 2, 3. So here when I print 5 elements are there. Here 6 elements. Here 7 elements. So my doubt is I represented here directly in this whether it is adding to the same list or creating a new list. Whether it's adding to the same list or creating a new list. Same list only because lists are mutable in nature. Lists are mutable in nature. So adding to same list. Done. Append method is clear. Run this program and see it. Lab 32 done. 5 elements, added 99 at the end, then 1, 2, 3 at the end. So append is for adding only single elements. Single element only. Single element only. Yeah. For your questions, yes guys, you have a next method. Extend method is there. Extend method. Add multiple elements from an iterable. Any iterable like a list, tuple, set. If you have any other iterable, you can add a multiple elements. If you want to add a multiple elements, then use extend method. These we will use later many times. Extend method is to add a multiple elements from a tuple. So I have a list of 10, 5 elements, my list. I have another list called fruits. Apple and banana 2 are there. So extend my list with the fruits list. So what is the becoming my list, guys? My list contains 10, 20, 30, 40, 50, comma, apple, comma, banana. Okay. This is my original list. Now, you guys have asked me the question as, can I have the single element as a list? What is the difference? Any different? You tell me what is the difference you understand as of now between append and extend? Append adds a single element, extend adds the multiple elements. Okay, very good. There is another crucial difference. Come back here. So my question to you, I have a my list which contains 10, 20. Okay. Append of, for clarity, I'll take apple, banana only. For append, can I pass a list as a parameter? For append, can I pass the list as a parameter? Answer is yes, you can pass. Yes, you can pass, Vishagar, but this will go as a one element. Currently, how many elements in my list 1? My list 1 contains a single element, and now this list will be added as a third element. List will be added as a third element. List will be added as a third element. It means after this, my list contains 10, 20, third is apple, and this adding as a list. List contains only 3 elements. First element is 10, second element is 20, third is the list. 3 elements only. But extends adds the list elements individually. Got it? Do you find a difference between append and extend? So append adds the one element. That one element can be a number, a boolean, list, tuple, whatever single element it adds at the end. But extend is, it takes the iterable parameter you are passing. These iterable elements will be collected individually and will be added to the list at the end. That is a clear difference. Clear, everybody? No advanced questions, Umesh. We'll come back one by one. I know your enthusiasm, but you follow me. All doubts, you will get it. So clear, guys? Append clear, extend clear? Can I move forward? Zip and append, you should not compare the output you see, Vishnu. For a zipping, you need a 2 lists, Vishnu. You have a 2 different lists. You have a 2 different lists. Zip, but append is, I have a list. I want to add a 1 element into that. That is an append. Extend is, I have a list, and see the output of extend. What is extend? You are adding elements of second list into the list. Finally, you will get a single list, right? You have the whole list, single list you have. But the zip is pairing of the first element of a list, first element of second list. Pair of second element of first list. Output you see, it is not same. How it is same? Are you seeing any difference in the output? Yes. Yeah, Abhishek, you're right. Zip is index by index pairing. First element, one pair. Second, another pair. Third, another pair. But extend is just you have other list, getting elements, adding into this list. You got a pure list finally. Okay. Then yes, next method, insert. Okay, moving to the next method, guys. Insert. Insert is like append. Append is general adding at the end. Insert is to add element at specified index in the list. Yes, you want to add in the middle. I want to add at specified index. You want to add. That's what Umesh asked previously. Umesh, here is answer for your question. Yes, you can add at any place. This is insert. Okay. So I have a list 10 to 60. I want to insert 99 in the middle at second index. So currently who is in the second index? Who is in the second index, guys? See, I have 10, 20, 30. I think you know the logic for indexing, insertion, all that, right? That logic might be already prepared. If you attended my data structure sessions, yeah, shifting, Abhishek, you're right. Shifting happens 0, 1, 2, 3, 4, and 5. Negative also we have, right? -1, -2, -3, -4, -5, -6. So at a 2 index, 30 is there. In that place, I want 99. So it will do shifting automatically. So it will do shifting first here. The 60 comes here, then 50 comes here, then 40 comes here, then 30 comes here, and then it will put the 99 here. Similarly, when I say 5 comma 1, 2, 3 at index 5. Now currently at 5, what is there? This is the 5, this is 6. Now automatically indexing will change. This is becoming the -1, right? So now 5, 50 is there. It will shift and insert at the place. At -1, I am inserting OK. This is the one important point you have to remember. One important point, guys. See. So initially I have this 99 inserted at second place. After that, 1, 2, 3 inserted at fifth index. Now the last point, you remember it. When I say insert at -1, which is the -1? -1 always represents the last. -1 always represents the last. When you insert at -1, it won't insert at last. It is inserting at last before. So generally you will assume as -1 means it will go for last element. No, the functionality, what they have written internally is insert at -1 will not insert at the last location. It will insert last before. Last before is -2. Do you understand? This is a key point to remember, guys. If you want, I'll write it here. The point, I'll write it here. Hash insert at -1 will insert the elements before the last position or before the last element. Clear? Okay. The remaining all you can do experiments actually. Fine. That's what okay. We are not seeing at the last. Okay, we are seeing here. Okay. Now Deepak asking us something. You tell me, Deepak, what do you guess? This is our current list, guys. You see the current list here on the screen. In this current list, what is the -1? Currently -1 is 60. This is -2, -3, -4, -5. Where you want -6. -6 means we have a 30. Am I right, Deepak? -6, 30. Okay, I'll do it -6. What I'll say? SR I am keeping. So tell me. So after 99, where it has to keep this? 99, you got this. At -6 only we got it. No. The -1 point, the rule for only -1, it is happening like that. Remaining all, it will keep at the respective places only. Remaining all, it will keep at the respective place only. Only for -1, I am seeing that behavior. Clear? Insert is clear? That is as usual, Sanjeev. Same generally. Yes, I didn't write a negative case here, guys. I didn't write a negative case. Okay, let's write one negative case. Instead of 99, comma, hello guys. I am asking, please insert hello guys at the 99 index. Print it. No index error. What happened? This comment I'll write on the about to the method to understand it. This is insert set minus sixth location only. Minus six index only. So what is the point to take? It's kind of append, right? Appending at the end. If index is out of bounds, then it appends at the end of the list. Appends at the end of the list. So it may be minus also. Let me try with the minus 99. Minus means, see, minus means it is putting in the beginning. How to write 2 points? If positive index is out of bounds, it appends at the end. If the negative index is out of bounds, then it inserts at the beginning. Then it inserts, instead of appends, I use insertion. Inserts at the beginning of the these all actually you have to do experiments, guys. If we start learning like the fresher, we will go, I think it takes a lot of time. Okay, fine. So I think insert also clear, everybody. Done. So from the methods of the list, we have done 3 methods. So one is the append, which appends at the end of the list automatically. Extend appends the elements of a table at the end of the list only. Insert, you can insert at any place. Okay. Now, still in insert, you can do experiment. What if I, second, what is that? Second is a specific element. What if I pass the list only here? You can do an experiment as element only. If I pass a list as it is as element, it will insert, right? Okay, guys. Remaining methods. So we have other methods from the list as a remove, pop, clear, index, count, sort, reverse. Sort, reverse are there. Sorted is different, reverse different. Global functions. Here they have a sort, reverse, and we have a nested list also. Multiple nested list. This we will see in the next session, guys. We'll see this in the next session.